Hello everyone, welcome back to the channel. In this video, we are diving into graph patterns matching with the help of Neo4j. We will try to cover following topics: how to find a fixed length and variable length patterns, finding the shortest path between nodes, and even working with nonlinear patterns in our Cypher queries. So first of all, it's important to create a data. So what we are going to do, we are going to create a data which shows a package delivery network. So that data will contain the warehouses, shipment, and how these warehouses are linked with each other, and which is connected with which warehouse is connected with which warehouse. Okay, so let me put down the query for this. So this is the query for creating the data set. So we can see here we have created the warehouses of all these different places. Then we have the shipments, at what time the shipment arrives, at what time it's being dispatched and what time it arrives. Then we have the links, how they're connected with each other. So let's say warehouse one is connected to warehouse two with this much distance. Then we have the calls. Okay, so basically call set is the shipment, which shipment stops at which warehouse. Okay, and then we have the next. So next is basically the sequence of stops in a delivery route. So let me create this particular data set, and now I will try to visualize this one. Match n, sorry, match n, return n. So we can see here that this is the data frame which we have created, the graph data. And here it's important that the orange ones are the warehouses, or you can say the yellow ones. I'm not that good at the color. So you can see this one, the yellow color or the orange color is it's the warehouse, depicting the warehouse nodes. Then we have the ones in this one is the shipment in the pink color. It's a shipment, which is basically an individual package tracking event. And then we have the calls at. So calls at is basically representing the shipment stops at a warehouse. Okay, so this shipment is going. This shipment is stopping at San Francisco dock. Okay, so like this, we can see the arrow also. This particular shipment stops at New York Center, and then we have the next. So next is basically sequence of stops in a delivery route. So let's say if we have a particular shipment starting from here, so it will go like this, and like this, and then it goes to the New York Center. So this is the sequence of stops in a delivery route. So what we are going to do is we are going to first find out the fixed length pattern. So basically, fixed length pattern helps us to find the relationship which occurs, let's say, n number of times. On here, n can be any number, one number of time, two number, three numbers, like that way. So so let me put the query. So what we are going to do, what we are doing here is basically we are trying to find the shipments here that are exactly two hops away. You can see here two hops away. Next is used here, and next is basically is the sequence of stops in a delivery route, so which are two hops away. Okay, in the delivery route. So this is very useful to understand the scheduled deliveries for a for the route, and it helps us to validate the routes also. So let me run this one. So you can see here. So this is the two hops, all the nodes, how they are connected and how they are hopping two nodes. Okay, so let's say we have 10,040. So this is the two hops. This particular part is two. This particular 10.0 is two hops. There one more hop, then one more hop. So there's a gap of two hops here. Okay, in all the shipments. So these all shipments are two hops away from the delivery route. So now the next thing is which we want to find it out is a kind of a variable length pattern. So variable length pattern is basically which helps us to explore a flexible number of steps like 1 to 5 hops. Okay, so the hops are not fixed. It can be anything. It can be, so we can provide a kind of a variable length. Like if we want all the hops between 1 to 5. Okay, so then let's say if we run a query where we have a shipment within 1 to 5 delivery steps from a starting shipment. So this is a kind of an ideal for delivery path expansion, especially when you don't know how long the route is. So so let me try to run the query. So what this query is going to do? This query is going to find out the um, all the shipments within 1 to 5 delivery steps. So let me run this. So we can see here. So it is going to give us the 1 to 5 delivery steps. Okay, from a starting shipment. So this is ideal for the delivery path expansion. Now, if there's also one thing, like if we want to find the shortest path. So Neo4j also provides a shortest path the function to find the quickest route between two nodes. So let's say if you want to find it out the quickest node between two warehouses. So let me run this query. So if you want to find out the quickest distance between the Chicago hub and San Francisco dock, okay. So then what will happen? It is going to use the shortest path, and here we have part provided the a. So basically a is the variable which is representing warehouse, and b is basically representing the San Francisco dock warehouse, and now it's going to return the path. So let me do the control enter. So you can see here this is the shortest path, okay, from Chicago hub to San Francisco dock, which includes the Seattle warehouse. So this way we can find the shortest route between the two warehouses. And So it doesn't matter that how many nodes are between them, but they are going to find it out the shortest path, which is the most closest to each other between the two warehouses. Then we can also find the non-linear patterns. So non-linear patterns are which helps us in more finding out a complex connections, such as triangles or stars or patterns involving different node types or multiple node types. So what we are going to do here is if we want to find it out two different shipments which stops at the same warehouse, so uh, we can we can run this query. So what we are doing here is, so basically we are trying to find it out all the shipments, okay, which is present, which is pointing out to a particular same warehouses, okay. So now what will happen, it's going to give the all the shipments, okay. So now let me do the control enter. So you can see here, so these two shipments points to this particular one, these two shipments points to this one. So these are the shipments uh which which points to the stops at the same warehouses, okay. So this way it's useful to detect overlaps, or to find out the congestion if there are so many shipments coming at a particular time to a particular warehouses, so it can cause congestion, or it can have a shared route or more traffic. So this way we can also find it out kind of a non-linear patterns. So this was and we can also find it out like how many warehouses are mutually connected, like you can find it out a two-way connection. um, so let me run this particular query. So here we can say link between the two warehouses, and then W1 is linked to W2 and W2 linked to W1. And then trying to find it out the distinct name of the warehouses which are connected with each other. So what will happen? Let me do the control enter. So you can see here there are no changes, which means that no warehouses are connected with each other in a bidirectional way. So if you look at the original data, so you can see here all of them are connected with a single line, single direction, unidirectional. So none of them have a bidirection. So if there's a bidirection, so then we can say that then it would have given some results. So so this was basically about this video. So we tried to explore the fixed length pattern, which is useful for known step traversal, variable length patterns for finding out a kind of a flexible path delivery, uh, and then we can also find it out the shortest path queries using the shortest path function, which Neo4j provides. And this can also help us find out the optimal route. Uh, then we have the nonlinear planner patterns for more advanced graph shapes. So, so this was all about this video. So if this helped you understand how to traverse analyze your graph using Cypher queries, so then please give it a like, subscribe, and let me know in the comment section what graph topics you would like to see next. Thank you for watching, and happy querying.